All right, here we are. Let's take a look at the different hormones that the pituitary gland secretes. So we've already covered this bit about the neurons that drop down from the hypothalamus are in the their synaptic terminals are in the posterior pituitary gland. So the paraventricular on the sides of the ventricles produce oxytocin, and the supraoptic above the optic nerve produce ADH. And interestingly, they're both composed of 9 amino acids. That's a small molecule. So we'll talk about diffusion a little bit later, but diffusion happens faster when the particles are smaller. So a small molecule like 9 amino acids is going to diffuse quite well. And they're very close to each other, but they differ in 2 amino acids. So that's like 2 9-letter words having 2 different letters can mean something completely different. And in this case, that does make a big difference. Oxytocin, a strong stimulant of uterine contractions released during childbirth, and also acts as a trigger for milk ejection or the letdown reflex. Both are positive feedback mechanisms. So we've talked mostly, and we will talk mostly in anatomy, about negative feedback mechanisms, where one thing goes up, something else happens to make it come back down, and we maintain balance. And negative feedback is about maintaining balance. Well, positive feedback is sort of like a snowball. I know we don't get snowballs around here very much, but the snowball effect where it gets bigger and bigger and bigger, and is a means to an end. It wants to take us to the conclusion of some event. And in the case of oxytocin, that event and the uterine contractions, that event is childbirth. So stress on the uterus gets relayed back to the hypothalamus, which causes the hypothalamus to release oxytocin, which puts more stress on the uterus, more oxytocin, and this whole thing feeds off of itself, getting larger and larger and larger effects until the child is born. And then when the child is born, the pressure is off the uterus and onto the parents. And then the whole thing can stop, and oxytocin release ceases. Positive feedback is pretty rare. Positive feedback in uterine contractions, milk letdown reflex, blood clotting, and there might be one more, but it's very rare, where negative feedback happens all over the place all the time. Antidiuretic hormone. The hypothalamus contains osmoreceptors that monitor solute concentrations. So the blood plasma has a certain solute, things dissolved in it, concentration. If we become dehydrated, that means that the water is gone, but the solutes still are there, and the blood becomes more concentrated. And so as that osmolarity of the blood increases, the hypothalamus interprets that as levels of fluid are getting lower. And if the concentration is too high, then that means the water levels are low. And so then the hypothalamus will secrete ADH so that we can retain water. The target cells for ADH are specific places in the kidney tubules. There's a bunch of different types of kidney tubules, these little parts of the kidney that actually do the filtration, called the nephron. And the nephrons, we'll hopefully get to that at the end of the semester, has a couple of different parts to it, and the tubes get named tubule, little tube. The tubules get named accordingly, and they empty into something called the collecting duct. And it's the cells in not all of them, but some cells in the collecting duct, not connecting, collecting duct, that are the target cells for ADH. And what ADH does is it causes those cells to reabsorb more water. And that way we would make a much more concentrated urine and retain water. Antidiuretic hormone, also released triggered by pain, low blood pressure, drugs. Don't do drugs. No, antidiuretic drugs. The release of ADH is inhibited by diuretics. So if somebody's got, say, congestive heart failure or high blood pressure, they might take an antidiuretic to lower blood fluid levels. One of the ways a diuretic would work would be to inhibit ADH release, inhibited by alcohol. So be careful there. And high concentrations cause vasoconstriction. That's another thing that would go to inhibit this vasoconstriction. Would also lower blood pressure, hence the term vasopressins, lowering blood pressure. And this diagram is also in your book, which is a good overview of the posterior pituitary hormones. Homeostatic imbalances. What happens if something goes wrong? Something always goes wrong with somebody somewhere in everything we talk about in this class. An ADH deficiency called diabetes insipidus, which is very misleading because this is not diabetes where you're talking about an issue with blood glucose levels. This has nothing to do with blood glucose. It has everything to do with ADH. And in diabetes insipidus, a deficiency in ADH is most typically caused by damage to the hypothalamus or the posterior pituitary. That can be from a head injury, a brain injury. It could be from something in a surgery that's gone wrong, or the presence of a tumor. Can all cause diabetes insipidus. It's pretty rare, only about 20,000 cases a year in the U.S. One of the signs is something that's very confusing: a retention of fluid and a high level of thirst. So somebody with diabetes insipidus would make a lot of urine and they would be thirsty. Now those two don't really go together. When you're dehydrated is when you have high thirst. When you're dehydrated, you don't make much urine. So when you're well or overhydrated, you make a lot of urine and you're not thirsty. So to be thirsty and make a lot of urine, those don't go together. All right, let's move into the anterior pituitary. 6 hormones. They're all peptide hormones. So they're going to be hydrophilic, right? They're going to be water-loving. Not so much. Well, yeah, pretty much. Sorry, I was thinking of something else. All but 2 of them are tropic hormones. There's that word there, tropic. That means that's a hormone that's going to go out in the body somewhere else and control another gland. So oftentimes you hear the pituitary gland described as being the master gland because it controls other glands. It's the anterior pituitary controlling other glands through these so-called tropic hormones. Now, I know when you look at that word, you want to pronounce it as tropic. Like that's where we should be, in the tropics, sitting on a beach somewhere under a palm tree with a little drink and an umbrella. But that word is pronounced tropic because it's not an English word. A tropic hormone is one that regulates the secretion of other hormones from other glands. And here they are: growth hormone, thyroid, the abbreviations are nice. You got to love this. Abbreviated GH, thyroid stimulating hormone, TSH. There's adrenocorticotropic, follicle stimulating, luteinizing, and prolactin. And they all do. Not only do the abbreviations make sense, but they all do exactly what they say they're going to do. Growth hormone. We'll just call it growth hormone. How about that? Does exactly what it says. It's going to cause the growth. And high levels of growth hormone will decrease the rate of glucose uptake, promotes use of fats as a fuel source, and triggers the liver to break down glycogen into glucose. There's an AMP1 topic for you. Remember what glycogen is? That polymer of glucose that's stored in the liver and large muscles of the body. So growth hormone is going to trigger the body, to the liver, to use more glycogen convert that into glucose, and then also to promote the use of fatty acids for fuel, and encourages growth through protein synthesis. So what else? Let's just jump right down to this third bullet here. Stimulates most cells to enlarge and divide, but the major targets are bone and skeletal muscle. So growth hormone does exactly what it says it's going to do. It's going to cause bone and skeletal muscle to grow and get larger. Human growth hormone is a common performance-enhancing drug. People would take human hormone, or HGH, to get bigger and stronger. And they probably shouldn't do that. Hypersecretion of growth hormone is usually caused by an anterior pituitary tumor, and in children results in gigantism. Maybe you heard of a guy named Tony Robbins, a motivational speaker. I've heard Tony speak. He's very good. He talks about his experience with the anterior pituitary tumor, which if they hadn't found it early and caught it, then he would have probably died. Gigantism. You get a large person. In adults, it results in acromegaly, where the hands, face, and feet get bigger. And Tony Robbins does have extra large hands and feet. And let's find somebody. Here we go. You probably recognize some of the guys in this picture, especially you wrestling fans. I'm not necessarily followed wrestling a lot, and even I know who these people are. On the left, or should I say, on the left, we have one Hulk Hogan, and on the right, we have Andre the Giant. And Hulk Hogan comes in at 6'8", 295 pounds. That's a pretty big guy. And he's facing Andre the Giant, who comes in at 7'4", weighing 525 pounds. I wouldn't want to mess with either one of those guys because I'm half that size. And I prefer to think about Andre the Giant in this picture. There he is on the right side of this picture. What's up, Andre? And look at that. Anyway, I hope you know what movie this is. If you have not seen this movie, I would find that just completely inconceivable. In my humble opinion, one of the best movies ever, The Princess Bride. So if you've never seen it, when you get a chance, watch it. You will not be sad. All right, back to the pituitary gland, the growth hormone at least. Hyposecretion, not enough growth hormone. You guessed it, you end up with pituitary dwarfism. And what you end up with is just a small person. And if we got hyposecretion of growth hormone in adults, usually causes no problems unless you're trying to go to the gym and build muscle mass, and then that might take you, it might not work as well. So here's a picture of all three. We have a normal sized person, we have an exceedingly tall guy, a giant, and we have the dwarf over here. Just the same proportions as a regular person, only smaller. All right, let's cut this one off here. By the way, just for the record, while I'm doing this, whenever my wife asks me to do something, whether it would be if she sends me a text message or asks me at the house, I have a standard response every single time. My response to her is as you wish. As you wish. And so I will see you next time.